Here's an overdue addition.
What's going on, everybody? Mortem here, this time bringing you my review after 100% TRPG. So if you're familiar with each of those genres, you might kind of get the gist of what they're breeding all sorts of difficulty, and then you can over the course of days. Every day you completely remove it. Another option available to you, though, is that each skill of the daughters can be upgraded with a memory, which are gained from killing enemies in combat.
If a police officer's at your door, here's what you should do. Police, open up. We have a warrant to search.
Here's an overdue addition.
हे गाइस, दिस इज योर होस्ट रैंग रियो मैन। जो है चेंजेस करने पड़ेंगे, ऑन एंड ऑफ करना पड़ेगा कौन सी सेटिंग को, इसको मैं आगे एक्सप्लेन करके पूरा बताने वाला हूँ डिटेल में। ये बस आपको सर्च करना है फीचर, और ये छोटा को जो है ऑन एंड ऑफ करना पड़ेगा, ठीक है, आपके जो भी आपको प्रॉब्लम आ रहा है उसके मतलब अकॉर्डिंग, ठीक है। सबसे पहले एक प्रॉब्लम आपको आ रहा है जो कि यहाँ पे देख सकते हो कि एरर कोड हाइपर वी इनेबल, यानी कि आपके पीसी में हाइपर वी इनेबल है, ठीक है। एंड मुझको जो आ रहा था कि मेरे पीसी में हाइपर वी डिसेबल था, तो उसको इनेबल करना था, ठीक है। ये दो प्रॉब्लम आ रहे। तो अगर आपको जो है आ रहा है कि प्रॉब्लम आपको हाइपर वी को जो है डिसेबल है, इसको इनेबल करो, तो सिंपली जो ये चेक बॉक्स आपको दिख रहे हैं ना, इसको सिंपली आपको राइट क्लिक करना, जैसे यहाँ पर दिख रहा है विंडोज़ हाइपरवाइजर जो प्लेटफॉर्म एंड वर्चुअल मशीन प्लेटफॉर्म, ठीक है। ये तीन ऑप्शन को जो है आपको टिक करना है। अगर आपको बोल रहा है कि इसको ऑन करो, हाइपर विजन को जो है ऑन करो, एंड अगर ऑफ करने के लिए बोल रहा है, डिसेबल करने के लिए बोल रहा है, तो सिंपली कुछ नहीं करना है, ये जो चेक बॉक्स आपको दिख रहा है बस इसको जो है अनटिक कर दो, एंड देन जो है आपको ओके करना है। ओके करने के बाद रिस्टार्ट करना पड़ेगा आपको अपने पीसी को, तो फिर जो है ये प्रॉब्लम आपके पीसी से जो पूरी तरीके से सॉल्व हो जाएगा। फिर मैं आपको आगे दिखा देता हूँ कि अभी मैं अपने पीसी को रिस्टार्ट कर लेता हूँ, आपको आगे दिखा देता हूँ कैसे मतलब प्रॉब्लम सॉल्व हुआ या नहीं। तो दोस्तों यहाँ पर मैं रिस्टार्ट करके वापस से आ चुका हूँ, और यहाँ पर आप देख रहे हो मैं जो हूँ MSI इमुलेटर जो है इसको इंस्टॉल कर रहा हूँ, और ये जो है इंस्टॉलेशन पूरा मतलब विदाउट एनी एरर जो है अभी इंस्टॉल हो चुका है। एंड यहाँ पर मैं आपको तो हे गाइस,
எப்படிலாம் எரராக வந்து உங்களுக்கு வந்து கேம் ஆட முடியல அப்படின்னு சொல்லி ஒரு கவலையாக இருக்கா? ஸோ நோ ஓரி அப்படின்னு வரும். ஸோ அதை ட்ரை பண்ணுங்கள், உங்களுக்கு வந்து எமுலேட்டர் ஓப்பன் ஆயிரும். ஸோ இது வந்து MSI ஆப் பிளேயராக இருக்கட்டும், இல்லை வந்து ப்ளூ ஸ்டாக்காக இருக்கட்டும், ஸோ வேறு ஏதோ ஒரு எமுலேட்டராக இருந்தாலும் சரி, உங்களுக்கு வந்து இந்த 3 ஆப்ஷனில் கேம் ஆட முடியும் உள்ளே போய். ஸோ வந்து ஃபஸ்ட்டு ஒரு டெக்ஸ்ட் வச்சு மாற்றிட்டு பண்ணணும். ஸோ எடிட் பண்ணி இங்கே வந்து பேஸ்ட் பண்ணிக்கோங்க. ஸோ முக்கியமாக ரன்னர்ஸ் அட்மினிஸ்ட்ரேட்டர் க்ளோஸ் மட்டும் பண்ணிடாதீங்க இந்த சிஎம்டி லேப்டாப். அதுவே ரீஸ்டார்ட் சர்ச் பண்ணி இப்படி ஷோ ஆகுதுன்னா அதை இப்போ டிக் பண்ணிவிட்டு கீழே ஓகே கொடுத்துருங்க. அவ்வளோதான், சிம்பிள். இப்போ வந்து இந்த எல்லா ப்ராசஸும் முடிஞ்சிருச்சு. சர்ச் பண்ணும்போது ஹைப்பர் வி மேனேஜர் அப்படின்னு சொல்லி காட்டணும். காட்டிருச்சுனால ஓகே. ஸோ இந்த வீடியோவில் என்ன பார்க்க போகிறோம் அப்படின்னு பார்த்தீங்கன்னா, இந்நேரம் உங்களுக்கு தெரிஞ்சிருக்கும், தம்ப்நெயில் பார்த்தா உள்ளே வந்திருப்பீங்க. எஸ், அந்த இஷ்யூவை பற்றி தான் பார்க்க போகிறோம். நான் வந்து இப்போ இந்த வீடியோ போடுறதுக்கான ரீசன் இவங்க கரெக்டு இவங்க தப்பு, ஸோ அதை பற்றி நான் சொல்ல போகிறதில்ல. ஆக்சுவலி இந்த சினாரியோவில் இருந்து ஆடியன்ஸ் என்ன அண்டர்ஸ்டாண்ட் பண்ணியிருக்கணும், ஸோ இந்த ப்ராப்ளமில் இவங்க பண்ண மேஜர் மிஸ்டேக், பிரியாணி மேனாக இருக்கட்டும், இல்லை இர்ஃபான் வியூவாக இருக்கட்டும், சம்மட் அதில் இன்க்ளூட் ஆனவங்க வேறு யாரோ அது ரிலேட்டடாக வீடியோ போட்டவங்க யாராக இருந்தாலும் இங்கே என்னென்ன மிஸ்டேக் பண்ணியிருக்காங்க, ஸோ அந்த மிஸ்டேக்கை தான் இந்த வீடியோவில் நான் ஃபுல்லாக சொல்ல போகிறேன். அதெல்லாம் பார்க்க முன்னாடி நீங்கள் இந்த சேனலை இப்போ தான் ஃபஸ்ட் டைமாக பார்க்கீங்க அப்படின்னா உங்களுக்கு என்னோட சேனல் நான் என்ன மாதிரி கண்டென்ட் போடுவேன்னு ஐடியா இருக்காது. அதை பற்றி கொஞ்சம் சொல்லிடுறேன், அதுக்கப்புறமா கண்டென்ட் போகிறேன். என்னோட சேனல் எப்படின்னு பார்த்தீங்கன்னா, டெக் ரிலேட்டடான வீடியோ, அப்புறம் வந்து கேமிங் வீடியோ, அப்புறம் வந்து கோடிங் சீரிஸ் ஸ்டார்ட் பண்ண போகிறேன். அதெல்லாம் வந்து உங்களுக்கு ஓகே அப்படின்னா சப்ஸ்கிரைப் பண்ணிக்கோங்க. அப்புறம் வந்து இந்த வீடியோ ஃபுல்லாக பாருங்கள். ஃபுல்லாக பார்த்துட்டு கமெண்ட் செக்ஷனுக்கு வாங்க. இவங்க பண்ண மிஸ்டேக்லாம் வந்து இப்போ என்ன அப்படிங்கிறத பார்த்துடலாம். ஃபர்ஸ்ட் வந்து பிரியாணி மேன் வந்து வீடியோ ஆரம்பிக்கும் போதே டிஸ்க்ளைமர் போட்டு ஆரம்பிச்சிட்டாரு. என்ன அப்படின்னா, இர்ஃபான் வந்து சம் வேர்ட்ஸ் ஹட் பண்ணது, அது வந்து ஹாமா பேசுனதை வச்சு தான் நான் இப்போ பேச போகிறேன். நான் ஃபர்ஸ்டே போட்ட வீடியோவில் வந்து நான் எதுவுமே இது மாதிரி ஹாமா நான் பிஹேவ் பண்ணலை அப்படிங்கிறத பிரியாணி மேன் வந்து ஸ்டார்டிங்கில் மென்ஷன் பண்ணிட்டு தான் யூடியூப்ல, அதாவது அந்த வீடியோக்குள்ளே போயிருப்பார். பட் இருந்தாலும் பிரியாணி மேன் பண்ணது வந்து அந்த வேர்ட்ஸ்லாம் வந்து கொஞ்சம் ரொம்பவும் மோசமான வேர்ட்ஸ் தான். ஏன்னா வீடியோக்குள்ள யூஸ் பண்ணதாக இருக்கட்டும், அண்ட் பண்ண ஆக்ஷன்ஸ் அதெல்லாம் இருக்கட்டும். ஆக்ஷன் நான் எதை சொல்றேன்னா, மிடில் வீடியோவில் வந்து இப்படி எந்திரிச்சு அதெல்லாம் வந்து கரெக்டான விஷயம் கிடையாது. ஸோ இது ஒரு மிஸ்டேக்கு. ஒரு கண்டென்ட் கிரியேட்டராக இருந்துக்கிட்டு உங்களுக்கு அவ்வளோ ஃபாலோவர்ஸ் இருக்காங்க, நீங்கள் வந்து ஒரு இது மாதிரி கான்ட்ரவர்சி ஆனாலும் இது மாதிரி வேர்டிங்ஸை குறைச்சிக்கிறது நல்லது. பிரியாணி மேன் வந்து நல்ல விஷயமே பண்ணியிருந்தாலும் இது மாதிரி வந்து கன்வேயிங் ராங்காக இருக்கும் போது அது நிறைய ஆடியன்ஸ் கிட்ட தப்பா
Hi students, Coming to our next topic, that is time stamping method. So what is this time stamping method? Let us see. Actually, a timestamp is a unique identifier. A unique identifier created by database management system. Created by database management system that indicates relative starting time of transactions. Relative starting time of a transaction. So that you call it as a timestamping. A timestamping is a unique identifier which is created by database management that indicates relative starting time of a transaction. So whatever the transaction you are doing, so it notes the starting time of your transaction and it always stores the largest timestamp. Okay, so at what time the transaction will be completed. Okay, it is a tag that can get attached to any transaction or any data item which denotes a specific time. So this time stamping can be generated by using system clock. Okay, system clock, or else by logical counter. So here the time stamping can be generated by using system clock at the time transaction started. So whenever the transaction is started, by the help of system clock, it knows the time at what time the transaction is started. So the time stamping method can be generated with the help of system clock or logical counters. So here the logical counter means it can incrementally logical counters every time a new transaction starts. Okay, every time, or else a logical counter is incremented after a new timestamp has been assigned. Okay, so a logical counter is there. It's always incremented by one after every new timestamp has been assigned to a transaction. So these are the two means the timestamping method can be generated by using the system clock or by using the logical counters. Okay, so let us take that suppose T1 is the transaction. T1 is a transaction. So this is a timestamp. So the starting T1 transaction, the timestamp is TS of 1. Timestamp of 1. Okay, so it continues. So after the transaction T1, T2 is started. So what is the timestamp of T2? Timestamp TS of 2. Okay, so here you have to be noted timestamp of TS of 1 means the starting transaction should always be less than timestamp of TS of 2 ending transaction. So this condition is very important. You have to be noted. So in the timestamp method, the timestamp of first transaction is always less than the timestamp of the next transaction or as the last transaction. Okay. So suppose an example, at the time T1 at 9 o'clock, T1 was started. So at 9:10, T2 has started. So timestamp of one transaction is 9. 9 is less than timestamp of 2 is 9:10. Okay, so always timestamp of 1 should be less than the next transaction or the last transaction. So this is the formula you have to be noted. Now coming to the timestamp values. Timestamp values. So what are these timestamp values? So there is two values were there, read timestamp and write timestamp. So that is our timestamp read timestamp of a data item. Suppose A is a data item or resource and W is the write timestamp of a data item. So these are the values, read and write timestamp values. Okay, so actually this read timestamp is the largest timestamp of any transaction that executed read successfully. So read data item A successfully. So the main point you have to be noted here is read timestamp means is the largest timestamp. You have to take the largest timestamp of any transaction that execute read successfully. So at what particular time the read will be successful. So you have to take that time as the largest time that will be denoted by read timestamp. And the write timestamp means it is also you have to take the largest timestamp of any transaction that executed write A successfully. So at one particular transaction, write will be successful. So you have to note that time. So largest time on write which it is successful. So these are the two timestamp values, read and write timestamp value. So let us see one example that you get some clear idea about what is the read time. The read will be successful. So you have to take that time as the largest time. That will be denoted by read timestamp. And the write timestamp means it is also you have to take the largest timestamp. Write is it is successful. So these are the two timestamp values, read and write timestamp value. So let us see one example that you get some clear idea about what is the read timestamp value and the write timestamp value. Okay, so let us take read timestamp. So the main point here is the largest value that read has successful, that time you have to be taken. Okay, so let us T1 is there, T2, T3, T4. 4 transactions are there. Those values 10, 20, 30, 40. Okay, okay. So these are the timestamp values. So at T1, read 1A, write 1A. Okay, so at R3, read A, R2, A. Okay, and W4, A. So this is an example. Let us see here. So what is the read timestamp of A? So what will be the value we have to find out? So at the starting, the timestamp will be started. Okay, so starting it should be 0. So next it checks. So at timestamp 1, read 1 A data item was read at T1 transaction. So update the value to update T1. So at the time the transaction should be it is 10. So 0 is less than 10. Okay, this is correct. Now next go to T3. So next read will be occur at T3. So update T3 is equal to 30. So that is 10. 10 is less than 30. Okay, this is also correct. Okay, means least transaction should be the starting transaction, or else next transaction should be less than next transaction. Now next transaction will be at T2. So let us see, update at T2 it is 20. Okay, so 30 is less than 20. Is it correct? No. So this will be false. So the least transaction read will be, so after T4 at T4 it is write operation. So don't bother about T4. So the transaction will stops here, and now the RTS value read timestamp of A is 30. Okay, so now coming to the write timestamp. So let us see what is write timestamp. So I already said. So the largest value where the write timestamp is successful. At T4 it is write operation, so don't bother about T4. So the transaction will stops here, and now the RTS value read timestamp where the write timestamp is successful. So here at T3 it is successful. So at T3 the value of the timestamp is 30. So 30 is saved in the read timestamp. So at read times the read is successful at the timestamp 30. Coming to write. So just take the same example. So update to T4. So T4 the transaction is 40. So 10 is less than 40. Right. Okay. So now the write transaction A is 40. Okay. So the largest transaction where the write operation is successful at 40. 30. Coming to write. So just take the same example. Write timestamp of A. So 10, 40, 10. This one all read. So write is 3. Right. Okay. So now the write transaction A is 40. Okay. So the largest transaction where the write operation is successful, that timestamp you have to be taken. So read
The way to think about a buffer manager is that in RAM it manages what's called a buffer pool, which is a set of page-sized extents in memory called frames. And it's the job of the buffer manager to provide the higher levels of the system the illusion that they're addressing and modifying disk pages that exist in RAM. But it's actually going to move pages from the disk into and out of frames in this buffer pool. The API at the two layers is fairly similar. The API to the buffer manager is going to be to read and write pages, and the API to the disk drive is also to read and write pages. But of course, in RAM, things are more addressable once you get in there in terms of addressing specific bytes within the page. So let's look at an example of how this might work.
Click the bell icon to get latest videos from Equida. Hello friends, today we will discuss about buffer management in a recovery section of the transaction management. We will discuss about the log buffering, the database buffering, what is the role of an operating system in terms of this recovery technique as buffering, and finally what is fuzzy checkpointing. Buffer provides an important role in the transaction management that we can have as in recovery of the transactions on this part of this operating system. Now the buffering can be done in many stages, like for these transactions can be also happen in many stages on the database management system. Now the first stage is in log buffering. What is a log? We know that log is required to maintain all the values for a data item that a transaction is operating. Now if the transaction is performing on some data item and the data item is not consistent on the completion of the transaction, then we can say that the data item is an inconsistent state. Now if we maintain a log of that particular data item, so now we can know that what value were the old values that were being written by the data item by the transaction. Now that we can provide this log as a part of this transaction management system, now if it is a failure on the transaction, then we can recover it from the transaction very smoothly with the help of these logs. Now what is mainly log buffering? That there is a buffer area or this buffer space where we can store the data for the log while all the logs are being performed for the transactions. Now if there are more updates, then we are storing all the logs first in this buffer area, and then finally we will store this buffer to the output disk as a result of that final log. Now what is this important of this log buffering? Because the log are itself very expensive, because it is storing all the versions of the data item that the transaction is performing. Now when the transaction is performing such data, then we can say that action. Now that we can provide this log as a part of this transaction management system, now if it is a failure on the transaction, then we can recover on the completion of the transaction, then we can say that the data item is an inconsistent state. Now if we maintain a log of that particular data item, so now we can know that what value were the old values that were being written by the data item by the transaction. Now that we can provide what value were the old values that were being set. Now if we maintain a log of that particular data item, so now we can know that what value were the old values that were being written by the data item by the transaction. Now that we can provide this log as a part of this transaction management system, now if it is a failure on the transaction, then we can recover it from the transaction very smoothly with the help of these logs. Now what is mainly log buffering? That there is a buffer area or this buffer space where we can store the data for the log while all the logs are being performed for the transactions. Now if there are more updates, then we are storing all the logs first in this buffer area, and then finally we will store this buffer to the output disk as a result of that final log. Now what is it important of this log buffering? Because the log are itself very expensive, because it is storing all the versions of the data item that the transaction is performing. Now when the transaction is performing such data, then we can say that all the logs are very expensive because they contain the detail, and now if in free time we want to update our database with this log of information, then it will be an expensive and also a tedious task for the database designer. Now what we do instead, we provide a buffer that stores all the logs for a particular transaction. Now after the transaction commits, then we can have that log be stored again back to the database as a part of this buffering transfer. Now as a result of this log buffering, log may remain in the main memory for a considerable period of time, like in this volatile storage. And after that, when the log will be updated with each of this rule that we will describe now, we can just put the log buffer updated to the disk log. Now what is a write ahead logging or val rule? So there are three rules that is associated with val. The first one is before the transaction commits, we must make this transaction commit, that is ti comment with this log. That means we must use the log to maintain the ti commit record. The next is when the ti commit is being put to this log before any commit that has been made to this database. So now we must need to perform the log entrance of this ti commit command, and then before the commit is actually taken place, we must replace it in the log. And the third one is that for the database that the log we are maintaining, we need to put the database log updation into the log first, and then we need to update the database according to the log. That means we are writing ahead logging. That means the writing on that particular data item or the log is performing first before that logging is done or the log actually is stored to the database. Now this rule that is val, which we are following, stands for that we are actually having a consistent data with the concurrent execution of the transactions. Now it permits for the redo information that we are having on the transaction. That means writing the data again and again in the log, but not the undo operation, which is performing once only when the log is being transferred to the database. Now this log-based buffering becomes extremely useful when we are having a database that is containing a large number of updates, because when there are updates that is more, we can contain the click the bell.
Hi students.
Click the bell.
Come back friend, how are you? In this video we'll talk about buffer management. To implement crash recovery system that ensure data consistency, we should have essential concept of the buffer management. Now there are three concepts: log record buffering, database buffering, and role of operating system in buffer management. Now log record buffering. At the time of creation of log buffer, process block B1 to be
It releases the lock once the block output has been completed. It is the size of the buffer so that other can use this particular portion. Now second approach, this is what our disk. Now we have to add additional remote disk. Welcome back friend, how are you? In this video we will talk about buffer management. To implement crash recovery system that ensure data consistency, we should have essential concept of the buffer management. We will talk about buffer management. To implement crash recovery system that ensure data consistency, we should have essential concept of the buffer management. Now there are three concepts: log record buffering, database buffering, and role of operating system in buffer management. Now log record buffering. At the time of creation of log buffer, it must store in the stable storage. So already you know what is stable storage. So this is what our say RAM, this is what our disk. Now we have to add additional remote disk, okay, to reduce the probability of crash, to reduce the probability of data lost, or to increase the probability of data availability. So this concept is called stable storage. That means we connect more than one disk, okay, in a remote location, so that if crashes will occur, so when this particular block is full, then we can transfer. So here, first of all, we have to wait till the log buffer full. Then and only at the time the log should be in what? It should be in RAM. After that, if it is full, at that time we can store in the stable storage. If crashes will occur, if we cannot arrange data from this, we can arrange data from this particular disk. Okay, this is what our stable storage. So at the time of creation of log buffer, it must store in a stable storage. So log buffer, we have to store this particular information, log information in the stable storage. That if we cannot, now log record buffering. At the time of creation of log buffer, it is a remote disk, okay, to reduce the probability of crash, to reduce the probability of data lost, or to increase the probability of crash. So we just wait. We should not store, just transfer. Okay, so we write log records to a log buffer in name memory temporary. and then store it. Now stable storage is what? It is a what? It is non-volatile storage, memory storage. So in memory. So when it is full, then and only we can apply. We can store it into the disk. So this is what our log buffer is in RAM. And this is what our disk, a single output operation. So when it is full, then and only we can apply. We can store it into the disk. So this is what our log buffer is in RAM. And this is what our disk. It is non-volatile memory. It is volatile memory. In log buffer, log records may reside in only main memory for a considerable duration before it is output to the stable storage. Now stable storage is what? It is a what? It is non-volatile storage, memory storage. So but because it is what? It is here we have to wait till the full log buffer full. That means what? Stable storage. It is in the what activity. These are the 3 points that we have to. It is volatile. If system crashes, that means we have to lose information. We lose information, log information. We lose the database activity. So definitely we have to impose some requirements. We have to import some rule, and that rule is called right after the PI commit. Log records has been output to stable storage. So first of all, after now see the PI, the information, the activity of PI must store in the log paper. So PI will commit. Before, after that, the log record is present in the stable state. After storing the log record in the stable state, then and only PI can commit. Are you getting this one? So if the log is present in the RAM, and at the time if PI commits, that means what? If system crash, that means what? We lose information about the log. Next we'll talk about the database buffer. buffering. If the input of the block B2 causes block B1 to be chosen for output, okay, all log related to B1 must be stored into the stable storage before B1 is output. Now we can see here, just we have discussed about that. Say this is what our buffer block, this is what our log buffer, okay, and this is what our work area. Now the suppose 1 GB is there, and here it is the actual data size what 3 GB. So divide into we need 3 blocks B1, B2, B3. So first of all use transfer B1 data, then return back, then transfer B2 data, then return back, then transfer B3 data. So that is the actual working principle, already we know. But in B1 data, while working with the B1 data, the activities of B1 must store in the log file. So before transferring data from RAM to B1, we have to transfer the log file into the stable storage. Then and only you can transfer B1. Are you getting this one? Then after transferring B1, we have to transfer B2, and all the activities are stored in this recorded in the log file. So before transferring B2 from RAM to hard disk, we have to transfer log file to the stable storage. Then and only you can transfer B2 in this particular disk, and after that we can transfer B3 here. Are you getting this one? The sequence should be as follows. So you have to maintain the sequence: output log records to stable storage until all records related to B1 have been output. So first of all, output the log record, output block B1 to disk. Then we can transfer B1 block from RAM to disk, and then input block B2 from disk to memory. Then after we can input B2, transfer B2 from disk to RAM. Just we have discussed. Okay. Now, so already you know. So to transfer from RAM to disk, we have to transfer B1 to. Before transferring B2 from RAM to hard disk, we have to transfer log file to the stable storage. Then and then we can transfer B2 in this particular disk. And after that, we can transfer B3 here. Are you getting this one? The sequence should be as follows. So you have to transfer disk. And after that, we can transfer B3 here. Are you getting this one? We have to transfer, then return back, then transfer B2 data, then return back, then transfer B. Block. This is what our log buffer, okay, and this is what our work area. Now the suppose 1 GB is there, and here is the actual data size what 3 GB. So divide into we need 3 blocks B1, B2, B3. So first of all use transfer B1 data, then return back, then transfer B2 data, then return back, then transfer B3 data. So that is the actual working principle, already we know. But in B1 data, while working with the P1 data, the activities of B1 must store in the log file. So before transferring data from RAM to B1, we have to transfer the log file into the stable storage. Then and only you can transfer B1. Are you getting this one? Then after transferring B1, we have to transfer B2, and all the activities are stored in this recorded in the log file. So before transferring B2 from RAM to hard disk, we have to transfer log file to the stable storage. Then and then you can transfer B2 in this particular disk, and after that we can transfer B3 here. Are you getting this one? Then and then you can transfer B2 in this particular disk, and after that we can transfer B3 here. Are you getting this one? The sequence should be as follows. So you have to maintain the sequence: output log records to stable storage until all records related to B1 have been output. So first of all, output the log record, output block B1 to disk. Then we can transfer B1 block from RAM to disk, and then input block now. So already you know. So to update the log, so here we store the activity of the B1. So while we are transferring log activity from RAM to disk, at that time we cannot update B1 value, B1 part. Really? We cannot update this particular B1 part. So we have to log this one. So that we have seen no update to B1 being progress while the system carries out this sequence of actions. Okay. Now we can ensure that there are no update in progress by using a special type of locking. So definitely we have to lock this one. So we have to apply the locking. Before a transaction perform a write on a data item, it must require an exclusive lock on the block in which the data item is set. That already you know. The lock can be released immediately after the update has been performed. So already you know a transaction wants to access some variable. First of all, the transaction must have the lock, exclusive lock. To update that particular variable. Same thing here we can implement. Before a block is output from transferring from RAM to disk, the system obtain an exclusive lock on the block. So first of all, system must lock it so that no one can change it, the content of the B1. The system obtain an exclusive lock on the disk to ensure that no transaction is updating the block, so that nobody can update this particular block. Now it releases the lock once the block output has completed. So once it is transferred, then and only you can release this particular block. It is also called latch. Are you getting this one? So once again I'm repeating the same thing. So the total data size is what? It is say 2 GB. But to transfer some transactions are using the B1 context. So we are here in log. We have to transfer. We have to record all the activity. Before transferring B1 from here to here, first of all we have to transfer log file in the disk in the stable storage. After that we can transfer B1. So while transferring B1 log file from RAM to disk, we have to lock this particular B1 so that nobody can change it. Okay, and after that, after log file transfer is completed, we can transfer block. So while transferring this particular block, we cannot release this particular log. Okay, after finishing this particular transfer, we can release this particular log. It releases the log once the block output has been completed. It is called latch. Now we can see here, this is what our disk. Okay, and this is what is in RAM. And here, read A is equal A minus 5000, WA, write A, RB is there. Now say we need two variables. The transaction T1 needs two variables, A and B. Now A is in block B1, but the value of B is in block B2. But presently, this particular block is the RAM. Okay, so in this condition, we cannot accommodate this particular block because B value is present in this particular block. Are you getting this one? So no space available to store B2 block where B is equal to 2000 is there. So transfer B1 from RAM to disk, but if system crash, the database will be in inconsistency. So before that store T1 A 5000 to 500, it is should be in the stable storage. Now this is one transaction. Here read A is there, A is equal to A minus 500 and WA. The value of A is what? It is 1000. It is present in block 1. But we need the transaction need another variable B, but it is stored in another block. But RAM can accommodate only one block B1. So to get this particular block B2 block, to access this particular value B is equal to 2000, that block must be transferred to the RAM. So before transferring to the RAM, we have to vacant that particular RAM. So we have to transfer B1 to the disk. So before transferring B1 to the disk, we have to store log file into the stable storage where the activities of B1 are there. Then and only we can transfer B2 to the RAM to maintain the consistency or to avoid the data loss. Next, the role of operating system in buffer management. We can manage the database buffer by using one of the two approaches. So two approaches are there, first approach and the second approach. So the database system reserves part of the main memory to serve as a buffer that it rather than the operating system manages. So here you reserve the portion of the RAM. Okay, so the database system allocates. So database system manages data block transfer in accommodate with the requirements. This approach has been drawback of limiting flexibility. The system manages data block transfer in accommodate with the requirements. This approach has been drawback of limiting flexibility in the use of main memory. So here we allocate the RAM or main buffer small enough that other applications have sufficient main memory available for their needs. So definitely we can restrict the size of the buffer so that other can use this memory of all processes in the system. Ideally, it should be in charge of deciding what buffer block must be in force output to the disk and when. To ensure the wall requirement of deciding what buffer block must be in force output to the disk and when. To ensure the wall requirement. So already you know what is wall requirement. So this is what wall is what write ahead log requirement. So ensure the write ahead log requirement that operating system should not write out the database buffer pages itself, but instead should request the database system to force output the buffer block. Okay, so here in this case actual control it is under the database system. So database system can swap the value or can use this particular storing data in the stable storage or using the log. It is under the database control, this one. But in the second approach here the buffer is stored in the disk. Okay, so the actual control is under the operating system. So to maintain this particular wall requirement, write ahead log requirement, the operating system requests the database system to perform this particular operation. Okay, so operating system transfer data into the RAM, then ensure the wall requirement. Okay, then and only RAM can retransfer this one. Okay, so to ensure the wall requirement, the operating system should not write out the database buffer pages itself, but instead should request the database system to force output the buffer block. Okay, and the database system in turn would force output the buffer blocks to the database after writing relevant log records to the stable storage. So that is the end of this particular video. Thank you very much.
Hi guys, welcome to my channel. Hi guys, welcome to my channel. In this video, I'll be covering what is normalization, and then I will explain what is 1NF, 2NF, 3NF, BCNF, 4NF, and 5NF. I will explain all these normal forms with examples. Guys, we also call normalization as schema refinement. So whenever you get schema refinement question in exam, you can write this answer. Guys, I have uploaded complete dbms subject tutorials. I will provide link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share, and subscribe to my channel. Let's get started. At first, I will explain what is normalization. Normalization is the process of organizing the data in the database. It is performed to reduce the data redundancy in a database. Guys, data redundancy is nothing but duplicate values. If you want to remove duplicate values in your database, then you need to use normalization technique. I'll give an example. For example, this is my college database. In my college database, if you want to remove If you want to remove duplicate values in your database, then you need to use normalization technique. I'll give an example. For example, this is my college database. In my college database, there is student table. In the student table, name, Sai, roll number 21, and section year repeated twice. Here, this record is repeated twice. This is known as data redundancy. Data redundancy is nothing but duplicate values. If you want to remove duplicate values in your database, then you need to use normalization technique. Data redundancy in dbms means having the same data at multiple places. If you have same data at multiple places, then we call it as data redundancy. It is necessary to remove data redundancy because it causes anomalies. Anomalies mean errors. If there are duplicate values in your database, then your database will work abnormally. And in every software company, there is database administrator. The main duty of database administrator is to maintain database. If there is data redundancy in your database, then it will be very hard for database administrator to maintain database. The main reason for normalizing the tables is to remove these anomalies. If we perform normalization on tables, then we can easily remove those errors. If we don't eliminate these anomalies, if our database grows, then we need to face data redundancy problem. And data integrity problem and some other problems. Data integrity means data will be correct and complete in our database. So definitely we need to eliminate anomalies. If we don't eliminate anomalies, then we need to face so many problems like data redundancy, data integrity problem, and some other problems if database grows. Normalization provides a method to remove following anomalies from the database and bring database to consistent state. Database anomaly means errors in database that occurs because of data redundancy, that is because of duplicate values. These are three anomalies. First one is insertion anomalies. Insertion anomalies mean we are not able to insert data in database because some columns may be missing at the time of insertion. I'll give an example so that you can clearly understand what is this insertion anomalies. For example, I want to insert new record in this table. So I want to insert name Raju, rule number 21, section D and age 19. This is age. In this table, there is no age column. In this table, only there are three columns: name, rule number, and section. But whenever I execute this statement, it will not insert this record in this table because age column is missing in this table. This is known as insertion anomalies. Insertion anomalies mean unable to insert data because some columns are missing at the time of insertion. Here age column is missing, so it will not insert this data in this table. Next, I'll explain what is updation anomalies. Updation anomalies occurs when the same data items are repeated with same values. Here name, Sai, rule number 21, and section repeated twice. This is simple example of updation anomalies. And last one is deletion anomalies. Deletion anomalies occurs when deleting one part of data deletes other necessary information from the database. For example, I want to delete this record, name Shiva, rule number 21, section D. But whenever I delete this Shiva record, it automatically deleted this Sai record and Ramesh record. This is known as deletion anomalies. Normalization works through a series of stages called normal. This Shiva record, it automatically deleted this Sai record and Ramesh record. I want to delete this record, name Shiva, rule number 21, section B. But whenever I delete this Shiva record, it automatically deleted this Sai record and Ramesh record. This is known as deletion anomalies. 21, section B. But whenever I delete this Shiva record, it automatically deleted this Sai record and Ramesh record. This is known as name Shiva, roll number 21, section B. But whenever I delete this Shiva record, it automatically deleted this Sai record and Ramesh record. This is known as deletion anomalies. Normalization works through a series of stages called normal forms. The normal form applied to a table is said to be in a particular normal form if it satisfies constraints. Guys, constraints are nothing but rules. We can perform Perform normalization on particular table by using various normal forms. These are various types of normal forms. I will explain each of them by giving examples. These are advantages of normalization. First advantage is it will remove duplicate values. That is nothing but it will minimize data redundancy. If we remove duplicate values, automatically data will be correct in database. Data consistency means correctness. Data will be correct in our database. And third advantage is integrity. Data integrity means whatever the data that is present in our database, all those data will be correct and complete. There will not be any missing values. This is meaning of data integrity. These are advantages of normalization. And next I will explain disadvantages of normalization. First disadvantage is if we perform fourth normal form and fifth normal form on tables, then performance decreases. And next disadvantage is first normal form disallows the multi-valued attributes. First normal form will not support multiple values. For example, for this person Sai, I want to give multiple mobile numbers. If you give multiple mobile numbers, this first normal form will not accept. A relation will be in 1NF if it contains an atomic values. Guys, atomic values means single values. For example, in table some columns contain multiple values. If any columns contain multiple values, then the table is not in 1NF. A table is said to be in 1NF if the table contains only single values. First normal form disallows the multi-valued attributes. Guys, attributes are nothing but columns. If any columns contain multiple values, then the attribute. After performing for B1, B1, and Raju. Now if you see this table, in the table is in second normal form. There are two conditions. First one is the table must be in 1NF. If you observe this table contains only single values. There are no multi-valued attributes. For this table contains only single values. Condition contain duplicate values. Actually, if you observe this table, in this table we can set primary key for this rule number column. But if you want to set primary key for this rule number column, definitely that column must contain unique values. There must not be any duplicate values. In this rule number column, there are duplicate values. Rule number 21 repeated twice, rule number 22 repeated twice, and rule number 24 repeated twice. A table is said to be in second normal form if the table is said to be in first normal form and there is no partial dependency. No partial dependency means primary key column should not contain duplicate values. But here there are duplicate values. So here there is partial dependency. dependency. Now we need this name. This is rule number column. In this rule number column, all values are unique. There are no duplicate values. Just there are unique values. Rule number 21, 22 and 24. Now we achieved primary key. This is separate table for no partial dependency and this is separate table for partial dependency. Here rule number 21 Telugu, rule number 21 English and similarly 22 English, 22 Hindi, 24 English and 24 Hindi. This is another table that contains partial dependency. Guys, you should not consider this table. We should consider only this table. If you observe this table is in first normal form. That means this table contains table must be in 1NF and there must not be any partial dependency. No partial dependency means primary key column should not contain any duplicate values. All values must be unique in primary key column. And whereas if you consider 3NF, a table is said to be in 3NF if the table is in 2NF and there is no transitive dependency for non-prime attributes. I will give an example so that you can clearly understand what is this 3NF. This is simple student table example. This table is in 2NF. That means each and every column contains single values and there is no partial dependency. That means this primary key column contains only unique values. So there is no partial dependency. So this condition is satisfied. And next one is no transitive dependency. So table is said to be in 3NF if it is in 2NF and there is no transitive dependency. So this table is in 2NF but there is transitive dependency because if you consider this table, this rule number column is primary key attribute. Attribute is nothing but column. So we call this rule number column as primary key attribute. Whereas if you consider name column, branch column and fee column, these three columns are non-primary key columns. So we call this name column, branch column and fee column as non-prime attributes. How can we consider fee? Based on branch. For example, for CSE fees is 30,000, for AML fees is 20,000, for DS 10,000 and for EC 5,000. So here fees column depends on branch column because based on branch fees is decided. But this branch column is non-primary key attribute and whereas this fee column is non-primary key attribute. Here only rule number is primary key and whereas this branch and fee are non-primary key attributes. Here one non-primary key attribute depends on another non-primary key attribute. If one non-primary key attribute depends on another non-primary key attribute, then there is transitive dependency. Here there is transitive dependency between these two columns. So this table is not in 3NF, but whereas in 3NF, the table must be in 2NF and there should not be transitive dependency. But here there is transitive dependency. Now we need to remove this transitive dependency. Here there is transitive dependency between this branch and fee columns. So you need to remove any one column. For example, I am removing this fee column. Now I will select only these three columns and I will create one separate table. After removing transitive dependency, my table looks like this. Here rule number is primary key column and whereas this name and branch are non-primary key columns. Now in this table there is no transitive dependency. So now this table is in 3NF. Here fee column is left, transitive dependency. So now this table is in 3NF. Here fee column is left. Now I will create one separate table for transitive dependency. So I created separate table for transitive dependency. Whereas this is table for transitive dependency and whereas this is table for no transitive dependency. Here in this table we achieved 3NF. This is known as third normal form. Next I will explain Boyce Codd normal form. Shortly we call it as BCNF. Boyce Codd normal form is an extension to third normal form. We also call this Boyce Codd normal form as 3.5 normal form. This BCNF is advanced version of third normal form. And whatever the rules that this BCNF contains, these rules are very strict when compared to third normal form. These are various rules in Boyce Codd normal form. And the first rule is A table is said to be in BCNF if it is in 3NF. And second rule is, for example, let us consider there are two columns. One column is A and next column is B. For example, this B column depends on column A. If B column depends on column A, then definitely this column A must be a super key. I'll give an example so that you can clearly understand what is this. This boys code normal form. For example, this is simple student table. This student table contains 4 columns: rule number, student name, branch ID and branch name. For example, the student name column depends on rule number column. For example, this rule number is X column and the student name is Y column. I already said before, if Y column depends on column X, definitely this column X must be a super key. As we know, we will identify student names based on rule numbers. So the student name column depends on this rule number column. If student name column depends on rule number column, definitely this rule number column must be a super key. Your student name column depends on rule number column. Definitely each and every student contains different rule numbers. We cannot give same rule number for two different students. So there are rule number 1, 2, 3, 4. All are different. That means all are unique. So this rule number column is super key. We will identify student name based on roll number. Similarly, we will identify branch name based on branch ID. Here if branch name column depends on branch ID column, definitely this branch ID column must be a super key. Definitely super key must contain unique values. So here first value is 121, next one is 122, next one is 123, and again there is 121 here. This column contains duplicate values 121 and 121. So this branch ID column is not a super key. Only if values are unique, then it can be a super key. But here there are duplicate values 121 and 121. So this branch ID column is not a super key. Now this table is not in boys code normal form because branch ID column is not a super key. There is high chance that two different students can take same branch. Now I will divide this table into two tables. One table contains rule number and student name, and next table contains branch ID and branch name. Whenever I create a table for branch ID and branch name, I will remove these duplicate values. Your student name column depends on rule number column, and in rule number column there are no duplicate values. All values are unique. So this rule number column is a super key. Now this table is in BCNF. This is branch table. In this branch table, branch name column depends on branch ID column. Here in this main table, 121 CSC repeated twice. Though 121 CSC repeated twice, I will write it only once. If you observe this branch ID column, in this branch ID column, all values are unique. There are no duplicate values. So this branch ID column is also a super key. Now this table is also in BCNF. Next I will explain what is 4 to normal form. Shortly we call it as 4NF. A relation with ID column, all values are unique. There are no duplicate values. So this branch ID column is also a super key. Now this table is also in BCNF. Next I will explain what is 4 to normal form. Shortly we call it as 4NF. CSC repeated twice. Though 121 CSC repeated twice, I will write it only once. If you observe one, so answers are study column. This 4 to this table. The student table is in boys code normal form. That means, for example, this course column depends on student ID column and hobby column depends on student ID column. If course column depends on student ID column, the student ID column must be a super key. all values are unique. So the student ID column is a super key. So now this table is in boys code normal form, and next there should not be multi-value dependency. Guys, multi-value dependency means, for example, if two non-primary key column depends on single primary key column, then there is multi-value dependency. Here course column is non-primary key column, and again here hobby column is non-primary key column. Here this course column depends on student ID column, and similarly hobby column also depends on student ID column. So there is multi-value dependency. Now we need to remove this multi-value dependency. No multi-value dependency means only one non-primary key column depends on one primary key column. So I will create two tables. These are two tables. Here this student ID is primary key column and course is non-primary key column. Here only one non-primary key column depends on one primary key column. So this table is in 4NF, and similarly hobby column is left. So I'm creating another table. The table contains student ID and hobby. If you consider this table, this hobby is non-primary key column, and whereas this student ID is primary key column. Here only one non-primary key column depends on one primary key column. So this table is also in 4NF. Only if one non-primary key column depends on one primary key column, then the table has no multi-value dependency and the table is in 4NF. So these two tables are in 4NF. Next I will explain what is fifth normal form. Shortly we call it as 5NF. We also call this fifth normal form as project to join normal form. A relation is in fifth normal form if it is in fourth normal form and does not contain any joint dependency. Fifth normal form is satisfied when all the tables present in dbms are broken down into as many more tables to ensure there is no redundancy. Guys, I will give an example so that you can clearly understand. What is this fifth normal form? For example, this is simple faculty table. In this faculty table, there are three columns: subject column, faculty column, and year column. For example, if you consider only subject column, we cannot identify the subject column uniquely because there are duplicate values. If there are duplicate values in particular column, we cannot identify the particular column uniquely. And similarly, if you consider only year column, we cannot identify year column uniquely because here one repeated twice. So we cannot identify year column uniquely. So that is why one column depends on another column. So there is joint dependency. That means one column depends on another column. But a table is said to be in 5NF if the table is in 4NF and there is no joint dependency. But here there is joint dependency. Now we need to remove this joint dependency. Just we need to break this last table into smaller subtables. And if there are any duplicate values, then we need to remove those duplicate values. For example, I will consider only subject column and faculty column, and I will create one table. And again, I will create one table for faculty and year, and again I will create one table for subject and year. So there are three possibilities. By creating subtables, if there are any duplicate values, you can remove those duplicate values. So I will create a table for subject and faculty. This is one table. Again another table for faculty and year. So Sai 1, Shiva 1, Raju 2, and Agenda 3. Create another table for subject and year. Here C1 and again C1. Next Java 2 and dbms C. Here subject C and year 1 repeated twice. So if any particular record repeated twice, you need to write that record only once. This is my top table: C1, Java 2, and dbms C. These are three possible tables. Guys, 5NF is nothing but we need to break down last table into smaller subtables. And if there are any duplicate records, we need to write the record only once. Agenda 3. But here there is joint.
Hi students, coming to the next topic in the subject database management system is decomposition. Now let us see what is the decomposition. So the name itself is saying decomposing means dividing. We are dividing whatever the table that is present, that we are decomposing into multiple tables. Dividing the tables into multiple tables. So why we are dividing this? So let us see what is it. So the main goal of decomposition. So what is the goal of decomposition? It eliminate redundancy by decomposing a relation into several relations in a higher normal forms. So that is a definition of the main goal of decomposition. So why it eliminates the redundancy of the table. What is the redundancy? Redundancy is nothing but a same piece of data is held in two separate places. Suppose the same data that is present in two separate places in the same table, then you call it as redundancy. Means the multiples. The same data is present in different areas in the same table. Okay. So to eliminate that redundancy, we use the decomposition technique. Means we are dividing. So the main goal of decomposition is eliminating redundancy by decomposing a relation into several relations. So a single relations will be divided into several relations. So whenever we are divided into several relations, we hope that it eliminates redundancy. Okay, so it is important to check that a decomposition, whatever you are decomposing the relation, that does not lead to a bad design. So you have to follow the rules. So based on the rules, you can divide the table into several relations, a single relation into several relations. So while you're decomposing the table, you have to be careful that it does not lead to a bad design. Now let us see the definition of this decomposition. Let me write the definition in the terms of relations. So let R is a relation, nothing but a table name. Let R be a relation schema, is a set of relation schema. Let us take a set of relation schema. So schemas are R1, R2, so and up to Rn. So these are the set of relational schemas. So different tables, means a single table R, a single relational table is divided into set of relational schemas R1, R2, so and Rn. Is a decomposition of the main table, that is the R. A set of relational schema R1, R2, so and Rn is a decomposition of R if it has to satisfy the condition R is equal to R1 union, R2 union, so and union Rn. So this is a decomposition. Means a main table, that is a relation schema, is divided into set of schemas R1, R2 up to Rn. Okay. So whenever you decompose tables after union also, means after combining those set of relation schemas, you have to get the main table. Okay. So let me take the example, then you'll understand. Let's take the relation. A relation R contains the attributes x, y, z. So this is R is a relational schema. So in that relation schema, there are 3 attributes x, y, z. There can be 2 subsets. Let us take 2 subsets. Means we are dividing the set of relation schemas R1 and R2. Okay. R1 contains x and y attribute, and R2 contains y and z. Means this complete relation is divided into 2 tables. Okay. This is R1 table and R2. R1 contains the attributes as x, y, and R2 contains y and z. Okay. So now we get the main relation R is equal to R1 union R2. So this is a decomposition technique. Okay, so just we divide the table into 2 tables. Again, the union means you're doing the R condition. R is equal to R1 union R2. So whenever you do the union operation or operation on these 2 relations, you will get the main relation. Okay, so there is a problem with decomposition. So whatever we are doing, we are combining the 2 tables. Then we are saying that we are getting the main table. Okay, whenever you combine the new schemas, you will get the old schema. But when you're doing this, there is some problem. So what is the problem? Problem with decomposition. Means you're doing the R condition. R is equal to R1 union R2. So whenever you do the union operation or operation on these 2 relations, you will get the main relation. Condition R is equal to R1 union R2. So whenever you do the union operation or operation on these 2 relations, you will get the main relation. Okay. So there is a problem with decomposition. So whatever we are doing, we are combining the 2 tables. Then we are saying that we are getting the main table. Okay. Whenever you combine the new schemas, you will get the old schema. But when you are doing this, there is some problem. So what is the problem? Problem with decomposition. Let us see what is the problem. So given an instance of a decomposition relation, we may not be able to reconstruct the corresponding instance to a original relation. Means while you're reconstructing, while you're reconstructing, means we are done in the union operation. While you're reconstructing, the corresponding information may not be available. Means whenever you're reconstruction, we may not able to get original relation. Okay, so after reconstructing, we may not getting the original relation. Means some information is losing, information loss. So that is a problem with decomposition. How the information is lost, let us see. Okay, I'll take one simple example. Then you'll understand what is how the data is losing while you're decomposing the table, and again you're reconstructing that. Okay, this is a problem with decomposition. Losing, information loss. Understand what is so that is a problem with decomposition. How the information table. So this is a ticket model. Suppose S20 200, and the category is Nikon. The price is 100. While changing the model name, the price is also changing. Now I'm decomposing this table. Okay, because this is you're having the redundant data here, so I want to decompose the table for this. XY Nikon, A20 Canon. Okay, now I'm taking the another relation R2. I decompose this table into 2 relations R1 and R2. Price, category, 100 Canon, 200 Nikon, 150 Canon. So up to here it is okay. So I reduce the problem of redundancy. So now no redundancy is there. Okay, reduce the problem of redundancy by decomposing the table. So after decomposing, you you have to reconstruct it to make it as a original relation. Okay, so now I'm doing union operation. R1 union R2. Okay, R1 union R2. So what are the fields here? Okay, again A11 prices. You're having two canons. The category for canon is you're having two. So A11 150 canon. Now S20. S20 price is 200 and this both are same, that is Nikon. Okay, again A20. A20 the price is here first, the canon category, the price is 100 canon, and A20 150 price and the category is canon. So if after doing these two are equal, this is the old schema, that is the main relational table, and this